Hello everybody, it's Mrs. Haynes. I am recording some little videos for those who are able to access, little boot camp type videos where we look at one kind of problem at a time. And I have a big disaster. Don't look at all my disaster, my mess. I wanted to look first today at problems that combine knowledge about percentages with knowledge about how to write an expression or an equation using that information. And these questions often have some scenario, you're selling something and you're going to increase the amount you're selling something by a certain amount, or maybe you're going to put something on sale and you're going to decrease the original amount so that it's costing less. When we increase the original amount by a certain percent, you can think of it like, make a picture. You can think of a picture here. I'm going to make a rectangle. And it's a 35%. So I'm going to make my rectangle into, I'll do 20 pieces. I'll do 10 pieces and then divide them all in half like that. That way I've got 20 pieces that are worth 5% each. So you can look and see what's happening. Okay, pretend those are all even sized pieces. Each of these pieces is worth 5%, so we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100% altogether. Your original amount is 100% of whatever x is, whatever your original amount. That's 100%. The whole amount is 100%. And so when you're increasing by 35%, let's see, that's 5, 10, 15, 20, 25, 30, 35, that's 7 chunks. You're going to be increasing, let's see, 1, 2, 3, 4, 5, 6, 7. You're going to be increasing by that much. If I had a value, like let's say it was $60, I could divide that $60 up and figure out exactly how many goes in each of these little spots, and then add that much more to it, and I'd figure it out. But this right here is 35% of x. That's what that piece represents. Now, to turn a percentage into a decimal, you take your percentage and you divide it by 100. And what that does without a calculator is, if there were a decimal point here at the end, it's going to drag it back 2 spots. So you're going to have 0.35, 35 100ths. So thinking about it like an expression where I have 100% of something, I'm going to increase, that means I'm going to add to it 35% of it. 35% of it is represented by 0.35x. So I have my full x plus 0.35x. That's one way to write it. That's one expression. Over here, this guy is 100% of x. How do you write 100% as a decimal? Well, you do 100 divided by 100. Functionally, that'll take your decimal point, move it back 2 places, so that equals 1. And that makes sense. I've got, anytime I have just x with no number written down in front of it, I've got 1 that's invisible, it's hiding out right there. I have 1x plus 0.35x. So I have x in both of these terms. I can push them together into one term. I have 1 plus 0.35 x's. I've got 1 here plus 0.35 1 here. So I can say, okay, I've got all these pieces plus these pieces. So 1 plus 0.35, let me write that over here, 1 plus 0.35, that's what I've got, times x. 1 plus 0.35, I put that in the calculator, I get 1.35 x. So these are 2 ways to represent the new amount. If you needed just the amount you're increasing, that's just the part you're adding right there. If you need the new amount, you can put them together. You can put it as two terms. You can put it as a term that looks like that. That's another way to write it. And you can put it as a term like that. They are all the same thing. They all represent taking 100% here plus 35%, squishing it together. If this is 100% and that's 35%, altogether I have 135%. And if I take 135% and make it a decimal, I'm bringing that point back to 1.35, and that's another way to think of it. So anytime you're increasing an amount, you're going to have three things you can look for to write an expression. You're either going to have the original amount plus that decimal part of x, or you're going to have 1 plus the decimal part times x, or you're going to have 1.35x. Now decreasing is kind of, it's very, very similar. You're going to have a starting amount, your total amount, and this total amount, that's your original. You don't have to use x, but a lot of the time in these problems you're going to see x. You might see another letter representing that original amount. Decreasing, let's say I'm going to put something on sale, or next, like 2 years, the second year in a row where I have a lemonade stand. I don't sell as much. I notice a decrease in 35%. I sell 35% fewer cups of lemonade. Decreasing means I'm going to be subtracting. And I'm going to use that same sort of thing to represent my 35% of x. So that's what that piece is. That's 100% of x, and that's 35% of it that I'm taking away. You could think of it like this. You could say, okay, if I'm taking away 1, 2, 3, 4, 5, 6, 7 pieces, what's going to be left? And I can go ahead and just cross them out since you're watching this video. 1, 2, 3, 4, 5, 6, 7. Let's cross those guys out. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pieces left. 13 times 5. Let's see, or you could do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. But that's one way to figure out what you've got. 10, 20, 30, 40, 50, 65. And what's left is 65% of x. Think of it like that if you want to. What you're going to see is, again, 100% of x is what you're starting with, and you're subtracting 35%. Maybe take 35 and turn it into a decimal. 35% is 0.35, or 35 hundredths. So that's one expression. The other thing you could think of is, well, I have two terms that both have x in them, and I'm going to have 100% minus 35%. And so what that looks like if you're doing the same kind of thing, 100% as a decimal is just 1. And so you can have 1 minus 0.35 times x. That's another way to write that expression. And then if you do the 1 minus 0.35, you're going to have 0.65. You can always just take your 65% and turn it into a decimal like that. That'll pull back twice, 0.65. 0.65x. So you notice they're very similar. There's again an invisible 1 in front of this guy. You don't even need to put it down. It won't usually be in your answer choices. You might see some distracting answers. Some distractors. You might see something like 1 minus 0.35x. You might see x minus 0.35. Notice there is not an x here. There is not an x there. This is not 35% of x, that's just 0.35. That's not 100% of x, that's just 1. So those guys are never going to be the right answer for this kind of problem. I hope that helps. It's a bit longer video than I wanted it to be. I had to pause it because I had kids coming in to talk to me. But I hope that helps somebody. If you have any questions, leave me a comment below. If you want to subscribe to my channel, you can do that as well. I miss y'all, and I hope to see you soon.